Welcome to Integrations and Observations. My name is Ali Yousefi. In this edition, we will cover unifying distributed systems logging with Azure Monitor.
So in this video, we're going to cover how to unify distributed systems with Azure Monitor. We'll first talk about why do I care about this? Look at potential sources, so from online to on-premise. We'll look at the Azure Monitor service itself, how to collect and correlate, how to analyze, how to visualize, and finally how to act on the data that we're collecting. So I hope you enjoy.
So why should we care? Well, traditionally, we would host our services on platforms that we owned in our own data centers, areas that we had more tight control over. With cloud-based services, we've sort of modernized this to have a hybrid approach or a full-on cloud approach across multiple clouds. And so having that control is not necessarily always in our possession. So we need to look at how we can you know, have that trade-off of the resiliency the cloud provides, the elasticity, but then be able to get away from what is perceived as a black box. And the rise of software as a service offerings such as Power Platform sometimes can be perceived as black boxes. So what we'd want to do is see how we can leverage existing log stores, mechanisms to provide events, metrics, and logs to this log store so we can analyze, visualize, and take action. So some of the potential sources are on-premise hosted services and infrastructure. So think of existing IaaS hosted services, self-hosted agents. So when we're working with Azure DevOps, GitHub agents, those can be leveraged for monitoring. Nodes, if we're looking at running Docker containers, for instance, or virtual machines, as well as on-premise gateways as well, can be monitored. And there's other options as well. For online or cloud-hosted services and infrastructure, think, again, software as a service like the Power Platform. The platform as a service, so Azure Functions. And then, again, infrastructure as a service, so Azure Kubernetes service, virtual machines, et cetera. Pretty much any service you could think of can have some potential to provide telemetry. So how we get that is what we need to do looking forward. And then looking as well to edge hosted services, so IoT devices, Raspberry Pis, et cetera, even wearables and bio, so phones, watches, glasses, chips, et cetera, can all be potential sources for telemetry. And speaking of telemetry, the Azure Monitor service, part of the Azure cloud, provides a very good way to allow analysts, administrators, developers to collect data points, to analyze those data points, visualize, and then take action. So for instance, we can collect from all sorts of resources and services, again, from on-premise to online to even other clouds as well. And again, with the IoT and wearable devices, we can analyze with log analytics, with application insights, with the RESTful API as well to work with sort of a data explorer, if you will. We can visualize with Azure Monitor Workbooks, with business intelligence such as Power BI or even Azure dashboards. And we can act. We can act with actions. We can act with smart detection. We can have our services help us by monitor and tell us where we may see some service degradations, for instance, some failure anomalies start to take place. We can have the service proactively tell us these things, and we can set up some automation using, say, Azure Automation, Logic Apps, Azure Functions, etc. So to begin, we really need to start looking at how to collect data. To collect data, we can have installable agents. These work well for VMs, for container instances, for even dedicated physical hardware. For services, we have APIs and SDKs, depending on what you're leveraging. If you're using, say, .NET, there are NuGet packages that can help provide some sort of SDK that you can leverage. If not, there's APIs that provide the flexibility. Most of them would use like an HTTP protocol, but they'll allow us to have that flexibility if an SDK is not available. And then also some services offer native configuration. So for instance, Azure Logic Apps has native configuration to log analytics, where Azure Function has native integration with Azure Application Insights. So once we've identified, and started collecting data, we need to start understanding how to correlate and enrich. So with correlating, you'll hear terminology such as traces and spans if you're working with the open telemetry specifications and terminology, and then sessions and operations when working with Azure Application Insights. These allow us to have a particular session with operations that can be an apparent child type flow, if you will, or can provide sort of an end-to-end, which is what we'll need when we start looking at how to trace through distributed systems. Finally, enrichment. We want to enrich with not only this session and operational information, maybe some user context such as geolocation, some information maybe about the user, and maybe some information about the particular event that occurred. Finally, just to touch on logs and metrics, just keep in mind when we're collecting, there's a clear distinction between logs, which are text-based. They're very useful for tracing. So think about eye tracing services and things like that. Useful for tracing and then getting to RCAs. Metrics are they're numerical based, useful for resource allocation, usage, and behavior. Think of CPU, memory, disk usage, etc. Just make sure whenever you start looking at potential solutions, in my opinion, I think you should look for anything that can work cross-platform, is flexible on what protocol it uses, and is reliable.
So for this demo, we're going to look how we can collect events from the Power Platform, including Microsoft Power Automate, Microsoft Dynamics 365, and even Azure services such as Azure Function. So we're going to look at creating a Postman post, kicking off a Power Automate flow, which will then kick off a Dynamics 365 plugin, which will then also kick off another flow as well. And we'll look at how we can correlate those events together in an end-to-end transaction. So I hope you enjoy.
Okay, in this demo, we are going to show how we can correlate events from separate systems that are hosted within the cloud. These are going to be all what we call SaaS, or software as a service systems. In this case, we're going to use Microsoft Power Automate. We're going to use Microsoft Dynamics 365. We'll have an Azure function that'll kind of be in between those. We'll show how, as a user, I can invoke a Power Automate flow through a standard HTTP call. That could be from Postman, from a console app locally, from a mobile device, whatever. In this case, we're going to show how we can create a record within the Dataverse or CDS connector, capture the request ID, populate that into App Insights, and then see how far we can go with that. So what I'm showing here is a previous run that shows a HTTP request that was received. This was simply called from Postman here. And in Postman, we can add various correlating IDs and what have you. So this was called, and I believe I should show, yep, Postman to my my Power Automate flow here. So calling the request, we're actually creating a new record inside of our CDS entity CDS environment for an entity called Insights. You can see here we can capture the ID of our Insight record, and we can get some of the more information about the record type itself. So going a little further, we're actually going to capture some information from the action. In this case, we can see we have the record set like we showed before, some workflow type activities here, or excuse me, data points here, and we also have some information from the output, which is what we'll need here. So we're going to look at the output headers, and in the headers from the CDS or Dataverse create method, we see a request ID, REQ_ID. It has a B8432, E46383C, 4FE6, B390, DB E5B2A76598. So this is the request that was the create method um, from our CDS or Dataverse connector here. And we can see that we have this Power Automate kit writing a request to our App Insights using the same ID. The request ID is the correlating ID, the timestamp, the name of the action. That can be whatever you want, and what was the response. In this case, it was 200. If it was a 400, some error occurred, you could also track that as well as a non-successful request. So what we're going to do now is pull up a plugin trace log. I have a plugin registered on create of the PEFP Insight entity here. We can see that we have a plugin step, and we have a request ID B843, which will match up very nicely with our correlating ID we have there. One more neat thing to just kind of fill out this demo is that I have another Power Automate flow set to kick off that says when a record is created on PFE Insights, I want you to kick off another flow. In this case, I'm creating a dependency record, and look, I can also get the correlating ID here, B843, so on. So in this case, what my demo has showed is that I've kicked off a request. I've had a flow that has created a record in CDS. I've had a flow that is registered to perform some additional actions on create of a record in CDS. So to tie it all together, so we can analyze, we can pull up our Azure function, and you can see here I'm sorting on the same correlating identifier using the transaction search, and I can see here that I have my initial request with my 201, and then my dependency here, which is my flow name. So in this case, we can see 2798A5, so on. That's actually the flow run name, which is, as you can see, is going to be here. So the name 2798 is actually, let's see if we can make this a little bigger. If you look, we can see we have the flow 2798. So it gets the flow run, the correlating identifier from the request from Dynamics, and we have also correlated to other plugins that may be registered here. So to take this one step further, you could also have the request ID or the plugin actually show up in our Azure function here. But if you want to view this in logs, you can view the log here and see some more information about how these started off, and how we have these identifiers to kind of relate them back here. So. All right, so to recap, we did a Postman post call, which kicked off a Power Automate flow that created a Dynamics 365 or CDS or Dataverse record. We noticed that the request ID header was populated from the output. We were able to track that with App Insights. We then kicked off a flow that was registered on create and we also looked at capturing that request ID as well. You can see here on the left, we have the REQ ID, and we have the request ID, which was the plugin trace log record here. All right, so analyzing data. So in Azure Monitor, two services kind of are there that reside. Well, there's a couple more, I guess, with service and resource health, but the main focus here is the log analytics workspaces and the Azure Application Insights service. For log analytics, provides a centralized log store. Can drill down to multiple services. You could span across multiple services and really drill into the data itself. And so when you use the logs tab within App Insights, that's actually rendering this log analytics kind of workspace here. Azure Application Insights more of a service on top of these logs that allow us to diagnose, troubleshoot, debug Includes the feature set such as end-to-end transactions, availability testing, user flow, some of these visualizations that we can have there. Allows us to do continuous export, create work items, have live metric streams, these kind of things. Also for Azure Monitor, last but not least is the service and resource health. So you can see how the data centers are looking, all your services and resource groups and what the health is there, if there's any sort of degradation and so on. And all of these can be alerted on, which we'll cover a little bit later.
So in this demo, we're going to cover the application insights availability test. I have a Azure function I'll show you that will connect to the common data service or Dataverse endpoint. We'll connect from various data centers across the globe and look at the availability results and how we can drill down into each one of them for not only availability successfulness, but then the duration as well, how long it took to run, say, a who am I request.
Alrighty, well, we have deployed our Azure function that we showed on the previous demo out to the cloud. I've deployed it actually to multiple data centers, and it's been running for at least a day now. You can see I'm already collecting. Overall, we're looking at 100% uptime, so that's great. You can see here in the availability feature, I can do things like scatter plots and lines, which, what's neat about the availability is that, I mean, I could see the 100% one, which is fine, but the scatter plot can also show me like durations and so on. So maybe I see here, it seems like there's a little bit of it's kind of skewed. So I could go see, at South Central US, this one said at Friday the 16th, that it looked like it was taking 8.7 seconds, which is a little bit out of the norm. This was 3.6 in West Europe and in South India. So here's what's fun about it, is that I deployed that same code that's running on the that's running in the Azure function on timer trigger. I'm not going to really show that, but if you work with Azure functions, you can kind of see how that would work. By using that environment variable, I can now, and using the same name, so an availability contract, having that name and setting that environment variable for a run location now allows me to group these by the various data centers they're running on. So I can see South Central US provides me 585 milliseconds to do my who am I call. West Europe, 888, South India, 1.04 seconds. If I want to choose, say, South India, I can get a nice little scatter plot of certain times, 2.7 here, 2.10, but we can kind of see it falls in between this, you know, 1.5, 500, 1.5 kind of thing. If I go here to South Central, very short ones, 204, 204, and then we have some of these that skew. So that's where you can also kind of like, if you want to start looking at percentiles and say, okay, get me the, you know, 75 percentile, 95 percentile, and try to get some of these outliers out and see like what the norm would be here. So you could do that, and then if you wanted to drill into the successful ones, you can run your end-to-end transaction detail. There's not too much going on here. What's neat about this is that since I'm collecting the custom properties, I could see, maybe the availability test, there could have been some issues because of the remaining XRM request or time remaining. This is for CDS API exclusively, but maybe you're running another API that has some sort of throttling or something that you could kind of look at these properties and see what was going on here. So that's using the end-to-end. If I want to, I can quickly, and if there's an issue, I can create a work item and have it integrated with Azure DevOps. But if I go to my logs here, you can see inside of availability results, this is kind of key. So it shows our scatter plot. We can see the results here, average duration, blah, blah, blah. If you just want to see, let's go just take a look at what's going on here. So I'm going to just run a quick query and see on all my availability results, West Europe, so on. So I could see that, this is kind of what it shows here, my custom dimensions. So I could see 530. So if I have one running at 530, 530 1 second, 530 1 second. And so all of these are using the same. What's interesting is this custom dimensions. I can see that my rate limit here, my external request rate limit, I see 5999. If I go to the one right above it, what do we think this would be? 5998. And just finish that one off. 5997. So what we're showing here is, not only the availability, but because we're collecting the headers from our SPN user, or application user, we can actually kind of see what the remaining requests are at any time. So maybe you could even use these availability tests as well to report on some other metrics. Again, like I said, the API throttling, the organization, um, build version, etc. So continuing our journey through Azure Monitor, we've now collected and correlated data. We have analyzed the data. Now we'll look at visualizing data. So we have a few options here. We have Azure Monitor and Azure Application Insights Workbooks. Those are useful to be able to, again, drill down into specific events. They have parameters and so on, and we'll have a demo of that coming up. Microsoft Power BI is a really useful tool to help, again, bring in not only our Azure Monitor logs, but then maybe logs from other log stores or just events um, from other services, as well as data from other services, right? It's got a rich data connector piece there. You can use the query language that's part of it to really kind of show how to build matrices and slicers and all this kind of thing. It's really neat stuff. And finally, Azure Monitor has dashboards that can be built so you can kind of have a holistic view when you log into the Azure portal of your different resources, so resource health, application insight logs, etc. And remember that these Azure Monitor services have a RESTful API. So if you want to bring in the data to your own, BI of choice, you have that option as well with the RESTful API.
So in this demo, we're going to look at Azure Application Insights Workbooks. Workbooks are a great way to share our findings with our team members, to drill down into specific events that may have happened. They allow us to add parameters, allow us to add markdown files, video links, navigation tabs, etc. So check it out.
Okay, for this demo, we're going to show how to visualize some of our data points we've been collecting with Azure Application Insights and Azure Log Analytics, part of the Azure Monitor service. We're going to look at looking at workbooks and how you can visualize um, various log stores, various app insights, various log analytics, bring them all together to have kind of a holistic top-down view of a particular area of interest. So in this case here, I have a workbook I've created called Dynamics 365 Performance Analysis. This would be useful if you want to maybe look at the performance of your Dynamics 365 API request, organization request, so on and so forth. Again, you can have this built in to your APIs and whatever you want to build it into. But what I want to show here is how with workbooks we can create parameters that we have. In this case, we can show, time ranges. We can show, how do we want to kind of sort our data by the mean, by the percentile, such as the 95th or 99th percentile, the different app names we may have here, and you can go dig a little deeper in here and see, for instance, on the P95 for the overall duration, at around 5 to 5:30, I saw a spike here of overall duration and operations. This was because of some previous demos I had, but you could dig into this and see that. Similar to like what we had the previous demo where we show the availability results, you can have something like that built into the workflow here. So if I want to choose an operation, I can click here and do that. Another one I have here kind of set up is one I've called user journey. And this one here has a time range, and again, another app that we would have, a UCI app for Dynamics 365. You can see here, I've done just some basic testing with Markdown. If you hit the edit button, you can see you can add, Markdown here for links. You can add, in this case, I'm adding badges from pipelines in Azure DevOps or GitHub. So we can show these succeeded and so on. I have some workbook parameters, just calling out some of the various properties of each parameter I'm using. Here I'm showing how I can collect parameters from queries that have run. So in this case, I have a query that is running here, doing a page view and getting a distinct authenticated user. What I'm showing is that by going to the advanced settings, you can choose to export a parameter. In this case, I can point to the field I want out of my query and give it a friendly parameter name, even default it if I need to. And that will allow me to use it going forward here. One thing to call out is that the user ID or any parameter, if you're going to use it for any other query to kind of set to be dynamic, you need to have it come below what you have here. So in this case, I can select user ID, and you can see that selected user ID is set to this 90F0, which is this one. But see, this one says unset. If I hit edit, you'll see that I'm doing a user ID here, which is the same one passed, but because it's above, it's not setting it. So you'll see this unset here, where below, it's setting it just fine, both user ID and user ID colon value. One thing to call out too is the text style. You saw that it was green for success. We have info, which is blue, upsell purple, and warning, which is orange, and red, which is error. So in this case, I can change it to purple. We have that. So I have my different sessions I can choose as well. And again, go further down and do things like see the user's most active page views, see their transactions with Power Automate, etc. I can create tabs for links, have URLs, even have it open up different modules here. In this case, this would be the user flow. You can set up a default user flow to render here. When you're done, you can actually share this with your colleagues. You can export, and there's the share, and you can also export the template as well, and actually share it with the community here. So it's pretty helpful what you can do. You can also bring in multiple sources, which is really neat. And here I can add resources, and I can add not only app insights but log analytics, maybe even other log stores I may have as well, maybe even blob stores and so on. You can also connect to resource health and resources. So for instance here, if I want to add a new, let's just say a new link, and here you can see I can add navigation. If I want, I can navigate to maybe a particular resource overview of some sort, choose the ID, which the ID would be in your, you'll see it kind of in your URL when you're looking at your Azure service, or if you're using an ARM template, you'll find it in there. You can have it open up. You can have external links as well to say like GitHub, wikis, or anything like that. So building these out, you'll have a nice list that you can share with your community. And also just to call out, there's some really great templates to get you started. So I can look at, say for instance, usage by hours of the day. Just click on that one. You can start seeing that when is the when is my application used the most. I can see today is at 4 a.m., 10 a.m. Sunday was used here, and then this would light up when you had a little bit more data points than I have here. But you can use that as well as maybe even looking at some failure analysis here. So in the last, let's just say, week, we can see that different this organization service request has 430, etc. I can see failed operations and so on here. And these are all based off of particular app insights that you set up. So if I want to go to maybe my Azure function that I know has been having some problems with availability, I can go look at it as well and see that my track dependency in the last 4 hours is at 58. What if I go the last 7 days? You see my success rate here. It's pretty rough on the dependency, only 33% for 38. I have 57 calls, 38 of them failed. So I can scroll down a little further and see all failed operations here and kind of dig deeper. So that's the workbooks really help us kind of drill down into particular items here. So failure code and top exceptions. Dependency, I'm having a who am I? 182 of these have failed. So I can drill into the who am I to see what's going on, to see if there's maybe a license has been revoked or the organization has been disabled, something like that. Finally, on our journey from Azure Monitor, we're going to look at acting on data. So one of the benefits of using Azure Monitor and Azure Application Insights is that, especially Application Insights has this smart detection piece to it. So you can train Application Insights to look for anomalies, so failure anomalies, performance anomalies, etc. It can look for memory leaks, can look for degradation of availability or services, for instance. For Azure Monitor alerts, these are configurable alerts that can help notify teams using distribution lists, notification hub for Toast notifications, Microsoft Teams, etc. with service hooks. If we want to go a little bit further into automation, we can look at running Azure Automation Runbook. So if we want PowerShell scripts to be able to be kicked off if something happens, we can do that. We can have Azure Logic apps run. We can have Azure Functions, and we can also have API webhooks that we can provide there as well. There's some other options as well, but the Azure the automate piece allows us to kind of just hook into services that can allow us to be a little bit more resilient and scalable if needed.
For the final demo today, we're going to look at creating Azure Monitor alerts based off of our Azure Application Insights data points from the availability results we ran earlier in an earlier demo. So we'll look at creating those to help us notify when there's a potential degradation to our availability.
All right, so finally in this demo, we're going to take some of the availability results that we're collecting. We're going to build out some alerting for us. So I've already went ahead and clicked from creating a query that we saw earlier. There's a button at the top of the log analytics kind of explorer piece that allows you to quickly create an alert role. So if you click on that, you should see something like this. You'll get into the search query piece here, which is the condition. In the query, you can set up you could create your own query, use the one that's from there. In this case, I'm showing availability results where my location is the South Central Data Center. All mine are 100%, but you could say like where false or where true, kind of shorthand for success or not. If you did where false, you could set that up, say, how many number of results? Well, maybe I need this to be, if there's any more than 0, this is a very important data center to me, and I want to evaluate over the last hour, let's just control, and then so on. And then when you're done, you'll set the frequency as well, like how often to run the query. So you can say done, and you can see here estimated cost because of the amount of times I'm going to be running it. Then you get into action groups, and you can set up certain things for emailing, right? Or you can, like for instance, if I want to create an action group here, I could set up, notify, and say notification type. I can email the ARM role here, or excuse me, Azure Resource Manager role, or do like we talked about, email, SMS. So SMS, Azure Push, voice, email. This would be interesting to see how you could connect it to the Azure Communication Services here. So you could set that up, and you could say, I want TOSO support at toso.com, and say, okay, great, and that's That's fine. We'll create that one. Well, if you get it right, you just give it a name, notify, and hit review, create, and hit create. And it's pretty quick there. It'll create the action group for us. And we can actually create another one, like I mentioned. You can have multiples here, and you can choose, do I want an action? Runbooks, Azure Automation. So that's PowerShell. Azure Function, I can quickly connect to a function and look, like I could say, track an exception here. So I could use my Azure function. I want to even kick it back, or I can kick off some sort of integration or like I said, redundancy pattern. Azure Logic App, you can again kick off quick logic apps as well. Let's see, what else do we have here? Secure webhooks and webhooks. So webhooks, you could connect to a third-party integration. You connect to a Power Automate flow, something like that. So you could set all these up. We'll just quickly say something like my function here, and just say track an exception. Hit OK, and we'll say track exception. And hit review and create basics. It needs a action group name, track exception. And hit review and create, and that again should go pretty quick. Go back. You could set up alert rules, so you could say track the South Central US data center, check your severity. Well, this is a big one for me, so I'm going to call it a sub 0. And then you can enable and suppress alerts here. So by quickly setting this, I can now have an alert rule that will now alert me when my availability tests are not successful or don't meet a certain threshold. All right, to wrap up what we've covered today, um, we covered how to collect, correlate, how to analyze, how to visualize, and how to act. So now with this knowledge, think and look at how you can review any sort of black boxes or what we think are black boxes for potential collection with installed agents, with even to a RESTful API, for instance. Think about how you can create visualizations such as workbooks to quickly identify and drill into to these data points to find that signal. Think about actions to help you react quickly, notify and automate quickly. Finally, look at how you can create work items to help remediate, right? These data points can automate work items and essentially provide a feedback loop to your development team, your IT team, to remediate any potential issue. And finally, these log stores can be extracted so we can learn from a historical perspective. We can apply maybe some machine learning to better understand kind of our trends and analyze that piece there. Well, that concludes this video. Thank you so much for watching. You can find my contact information in the bottom right-hand corner. Feel free to reach out with any questions or comments you have. Thank you.